All right. So what we are seeing is a special property that you can easily observe once we do this. So let's import a table into Hive. Before importing, what I'm going to do is I will look at the existing tables and let me clear off these tables. Drop table, departments, I don't want it. Drop table, DPT, right? And if you now look at show tables, it's very clear we don't have departments table and DPT table. Go to another command prompt and execute your scoop command. Where is it? Is there a scoop command available? I think it should be available in the yesterday's one, right? Control D. I think if I use this terminal, I will get the scoop command. No. Scoop import, because you're importing into Hive, minus connect jdbc :mysql / localhost :3306/retail_db. In certifications and all, this is a 100% question. Import data into a particular table. So jdbc localhost and then minus username, give retail_dba minus password Cloudera minus table. Make sure that the table that you're importing is having primary key, so we will use departments as the name of the table. Minus what are the options? Hive import, right? No, Hive
import.
Hive import.
Hive override.
And that is if it is existing, right? Hive override. That's all. The job is getting executed, and as you can see, it has run and successfully without any errors. And now you go to Hive and look at show tables. You should have the departments table, and now right select star from departments. You should have all the 6 rows from the original table, right? So I think the original table we changed with that 1000 value. Let's clean it up. That's not a problem, but just let us clean it up so that it is maintaining the original one. Minus u retail_db a and minus p, and then Cloudera, and use retail_db as your database, and show tables. You have all the tables. Control L, and now what is that? Delete from departments, where department_id is equal to 1000. Spelling. All right. Don't worry, when you imported it, we have all these rows that are available. The question is this: export from this Hive table to MySQL. What's the difference between what all we have learned yesterday? Very important, very important. Yesterday we learned how to export from HDFS. Is it not? Export directory. You gave always the export directory. Now the question is this: I'm not telling you to export from HDFS, I'm telling you to export from Hive table. to MySQL. How will you do that? Warehouse directory is only used for import. Don't make any mistake. Warehouse directory and target directory are used only for import command. No. Answer is you cannot do. You cannot export from a Hive table by using some command. What you need to know is, remember, Hive stores the data where? HDFS. So ultimately the question is what? Exporting from HDFS. It's a tricky things, right? But you should know where is the data. And you already know that Hive uses /user/Hive/warehouse as the default directory. But how will you know in your company whether they are using that default /user/Hive/warehouse? They can create anything, right? It's admin's work. So now comes a beautiful command. We never used this, I think. You know very well that if you write describe and if you write departments, it is going to give you the structure. This is the Oracle command, but there is something which Oracle also cannot give you, but Hive can give you. What is that? If you write describe, what is the word? Formatted departments, and now you press enter, you will see amazing things about your Hive. So never use describe command alone. Always with Hive use describe formatted. And what are the things it is going to tell you? Look at the things. The column name and the data type. That means this particular table is containing department ID and a department name, which is the usual information that you get, right, when you write only the describe command. And then you will see a section called detailed table information, and it will tell you, okay, this table is in the default database. The owner of this particular table is Cloudera. It was created just now, okay, because the Cloudera virtual machine is in PST, it is showing that. And please look at this. This is what we want. Where is the location of this particular data? User/Hive/warehouse, luckily, because if it is a different company or somewhere, you may see /babyc/p2r, something like that. You must type this to know where exactly is your data. So you can see user Hive. And another very important thing, I don't know how many of you remember, in Hive you can create two types of tables. External tables and managed tables. External tables means you will be pointing to data, and when you drop the Hive table, the data will not be deleted. Managed table means when you drop the table, data also will be deleted. I told you many times this one. Alright? This is the command that you should type whenever you want to know information about your Hive. Okay? Now comes a very big problem. Okay? So you got everything. Now I am going to export it. So what is our directory name? User/Hive/departments, warehouse/departments. And remember, you may want to write all these things completely, but even if you don't write, by default it will take that particular value. So you can just like write /user/Hive/warehouse/departments. Now let us come to our scoop command that we have learned yesterday, right? And come to that scoop command prompt, clear the screen. And what I am going to do is, I am going to write the command now, and please look at the command, and it is going to fail. Don't ever write anything. Export, scoop export, and it is going to export, but it has to connect to this particular table, and I cannot have the same name as the table. Why? Because I am going to create an export from my Hive table to another table, and you know that another table will not have primary keys, so don't club it with departments table. And you don't need Hive import and Hive override. Why? Because these commands are used for import, not for export. And you know that you have to give export directory, and you already got that information. /user /hive /warehouse /departments. That's the export directory that you should be using. So this is what you should follow when you want to export Hive table into this one. The admin or anybody in your organization will not tell you. They will tell you export this Hive table, but you should know where the Hive table is storing that information. And it will fail. And can you tell me why it will fail? There is no problem in the command, right? Oh, sorry, I think there is a problem in the command. What is that? You should have created the table. Yesterday you had the same error. What you have to create? Create table dept as select star from departments where 1 equal to 2, correct? And now you go back. That's not the error, okay? For now that is an error, but still it is going to fail. The map reduce is going to kickstart, no problem. So you can see, as usual, the map reduce is running. I'm telling you very internal about Hive now. It should fail. Yes. Error during export. Exported 0 records. Look at the first line. Anybody? What's the reason? No, why exporting? There is no problem with it. There is a big difference. Please remember, when you use import command, you can import to HDFS, correct? Using the warehouse directory or target directory, or you can import to Hive, just like what we have done just now, by using Hive import. When you use Hive import, it will be imported into Hive. When you use warehouse directory or target directory, it will be imported into HDFS. Yesterday I told you that in HDFS, whenever you are importing, the default delimiter is comma and the line terminator is new line. That is a very important lesson. When you import into Hive, if I intentionally didn't show you the other part and you didn't ask that other part, right? Previously when I was showing you the describe formatted command, look at that storage information and read it down. It is not comma when you import into the Hive. It is a character, actually 4 zeros, 3 zeros also will work. It's a Unicode character, which is the default delimiter. Now when you write an export, it will work. Why? Because the default Hive will take comma, but now you exported from the Hive's directory, it will not take it. So what you need to do, you need to do a trick. I will show you this. Where is the directory where the Hive is storing the data? user/hive/warehouse, right? Please look at this. I'm going to clear the screen. Hadoop fs minus cat /user/hive/warehouse/departments/part star or part dash m dash 1 2 3 4 5, right? Look at that. 0001. What you could have seen if you have imported into HDFS, you could have seen a comma there. That's the problem. Originally, this took my 8 to 10 hours 3-4 years back without knowing the problem. It's not, I don't think it is there in the Google. Alright, so what you need to do is, how will you write a Unix command on the Hive prompt? I told you all these things.
You have to use exclamation.
Correct. Exclamation, clear, semicolon. Exclamation, clear, semicolon. Any Unix command, exclamatory mark. How will you run a HDFS command at the Hive prompt? I told you that also. Can I write hadoop fs minus cat here? Yes or no? I cannot. Hadoop fs minus command can be written only at the $command prompt. You are in the Hive prompt. You should use dfs, not hadoop fs. So dfs fs minus ls, yes, it will work. Oh. What is that? dfs minus ls? Yeah. No need of writing hadoop fs, dfs. Okay, so any command can be written in the Hive prompt also without opening a Hadoop prompt. So how are you going to do that? So let's write that particular command. Scoop export again to make sure that it is working. So come to your Unix prompt and execute the same scoop export command, but this time please give minus. Okay, somebody asked me how to give the delimiter and all. I think Suresh. Input fields terminated by is a long word. Input fields terminated by minus input fields terminated by, as I told you, it is 001, and then minus input lines, input lines terminated by, there is no change, it's new line. You can use a single character as well, because new line is always a single character. Now Hive will not take, export will not take the default comma, it will take what you specified. Press enter. You should get a message, exported 7 records, 7 or 8, whatever it is. I think it is 7 records, right? Because we have the 1000 as well. Look at that. And if you log into MySQL and you do the select, now you will get the complete data, right? So please remember this. This is all you need to know in scoop. Rest, so many options are there. I told you yesterday that please spend some time, scoop user guide. There are so many options. Click on the user guide and you look at scoop import, purpose, syntax, and you see if the people who are there related with the mainframe here. Let me tell you something which I did for SBI. Okay, it's beyond our scope because we don't have any mainframe environment. In mainframe, the king, right? Nobody ever could touch. Nobody ever could think of replacing it. Banks to healthcare to any place. Even today, even though it was in 1960s or 70s, nobody can even match the transactional integrity and the power of a mainframe. Controlled instruction set computer system. 6. Whenever you execute a particular job, that job will take the processing power of the mainframe, which is measured in, what is it called? Millions of instructions per second, or MIPS. Any transaction that you do on this MIPS, the companies charge you based upon the MIPS. Very simple. 5,000 MIPS per month will cost you about 5 million. 5 million. Banks and all will have about 50,000 MPS to 100,000 MPS, which is the biggest revenue of 50 million to 100 million per year. That's how they survive. Imagine transactional systems you cannot replace. I already told you many times. So there are so many. For example, buffet system, which is used in ATMs for banks. You can't replace it. It's a C++ based code, assembly language code. And that code is communicating with the mainframe in the bank through the gateway called Visa or MasterCard. You can't replace that. That's a transactional system. But at the end of the day, so many data warehousing, like your PLSQL procedures, so many other things are going on inside this, which is why it is 50,000, 100,000 MIPS. If you look at only transactions, it may be 1,000 MIPS. But because of so many other things, just like your Oracle databases and Teradata databases, right? All the other work that is happening, that procedure, this procedure, that PLSQL code, that trigger, that packages, that kills, right? Extra money is coming in. And it's like God's blessing. And please look at this, what they have done. You can directly import the data by using scoop import mainframe command and import it into a database, and now you run all the procedures, expensive things on that database, 0 MIPS, and the cost save is 25 to 30 million per year. So if you are daring, take up that challenge in your organization. I can change the mainframe processing into my big data environment by using that particular command, and then get that particular data, right? A big saver. So please go through this scope. What I told you is 10% of scope, but the overall, the core heart of scope, the concepts. Now you look at the syntax, okay? And just look at all the options. What is meant by connect? What is meant by connection manager? What is meant by password file? We are always typing minus password equal to. No, it should not be, right? It should be in a file, and then you should be able to read from the file. All that particular options are there. And if you are coming down, then you will see all the other options, right? Look at this. As Avro data file, as sequence file, as text file. By default, it is as text file. Look at this. As default is text file. That is why always we are storing it as text file. You want to store it in another format. I already told you in Hive there are 4 formats. So if you want to store it, then use those particular thing. You want to change the columns, just to take only the columns, what Suresh has asked, right? You can take that particular data. You can tell that at that time how much data has to be fetched, fetch size. So just practice by using all these things. right? The basic command, the heart of the command is what you typed. For everything, you need that. For importing to Hive, exporting to Hive, remember that export Hive, you have to give that Unicode character as the input terminator. Okay? The next topic is partitioning. How to do Hive partitions. Okay? So let's take an example and let's do it. And this I would like you to do. After I complete it, I will give you some time. Okay. So what's meant by partitioning? And we never did partitioning in Hive. We did partitioner in MapReduce. We created partition, right? So let's start with this, okay? So I'm clearing the screen and we will delete that particular table from MySQL. We don't need that table. Drop table DEPT, okay? Again, don't do anything on the departments table. Be careful. And in Hive, we don't need the table called departments. Right? First, let's do something, and please observe all the steps. This is a very important, another important concept which you will have everyday practical use. So scoop import. I'm going to bring another table which is having 68,883 rows called orders. Okay? All the things are correct. We are importing into Hive, no problem. It will take a while because it is not 6 rows or 7 rows. It is 68,883 rows. All right, we have imported it. Go to Hive. Orders table. First, let me show you the columns. Describe, formatted, orders. How many columns are there? Order ID, order date, order customer ID, order status. Int string, int string. Right? Let's do one query on Hive. Select. I'm doing an aggregation. You know why I'm doing an aggregation? Because I want MapReduce to get executed. Count star from orders where order underscore status equal to, there are different statuses. Let's use the status called pending. You will see pending, hold, all these are different status in the orders table. You can just check it. What will happen? It will definitely run a MapReduce. If it is select star, it will not run a MapReduce. You can see there is a reducer as well, because the moment you write an aggregation, no way. All right, 7,610. Pretty fast. We got the answer. Go to the Cloudera. Look at the statistics. You will see that select count star has executed as a MapReduce job. Click on that. Go to, is it logs? No. Go to history and remember all the things that we learned. Look at counters. Okay. Job counters. Map input records. 68,883. Very, very important. So your MapReduce program, while it is getting executed, that map has taken the entire data, correct? And then found there are 7,610 rows which are having order status as pending. Right? So you have the orders table. The data is in HDFS blocks. So node 1, node 2, node 3. It is all distributed, your entire data. Of course, in Cloudera it's only one node, but in the ideal situation, different nodes. And when you run the MapReduce, entire data, 68,883 records are being executed, and it has given you the answer as 7,610 rows are pending. Can you make it more efficient? The way that you can do is assume that all the pending data is in this node, all the hold data is in this node, all, let us say, suspended data is in this node, and now if I run a MapReduce and if I ask for the status, rather than scanning the entire partitions, it needs to scan only where the status is pending, so that only total 610 rows will be scanned and 610 will be the result that you obtained. You got a drastic performance improvement. So when you are searching by date, if you are doing a date partitioning, faster, right? This is what Oracle does for some tables internally. Here you have the flexibility of creating that partitions by yourself. So what we will do, we are going to create partitions based upon the order status. So how you are going to do that? Look at this. Control L. I am on the Hive prompt. Okay. First create my orders. Remember, I am not creating orders, but I am creating my orders table. And I am going to give the columns. I did all the columns, right? And what are the other columns that are there in the data? Remember, there was integer string, integer string. So order ID integer, order date integer, order underscore customer underscore ID integer, and look at the new word that you are studying now, partitioned by order status, which is a string. Just give me a minute. I think one was a string. I put a big int copy. Wait a minute. Describe formatted orders. What is the data? Oh, order date is stored as a string. So order ID is integer, order state is a string. So I'm going to go here and Control L, and I'm going to paste what I have copied because I want to make a change. The order date is a string. Okay, So please look at the command. Whatever you need to create as a partition, create it as partitioned by. Can you have multiple partitions? Yes, it is possible. You can write order status string comma order date. Then it will be partitioned by status as well as date. Okay. So once you do this, the table is created. Oh, it should be integer. There is a table. There is a problem. Control L. What status column? Huh? All SQL kings are sitting here. I was missing the word table. So create table, and then you are creating that particular table partitioned by. Okay. And now see the next command. What is the table that I already have which is not partitioned? Orders. Insert. Okay. The syntax is very, very important. Okay. Overwrite. Make a note. Table. Which table we are going to overwrite? My orders, because that's a new table, right? And when you are doing it, use the partition order underscore status as the partition. Select order underscore ID, comma, order underscore date, comma, order underscore customer underscore ID, comma, order underscore status. From orders where order underscore status is not null. Many things to understand from this. Please listen before you type it. First thing, you are creating a partition table, my orders. And what is a partition column? Order status. So the partition order status you have to give in bracket. The most important thing, whatever you give here inside this particular bracket should be the last column in your select, otherwise it will not work. So if you write select order status as the first column, it will fail. Whatever is given. So if I give here order status comma order date, it should be order status comma order date here. Yes, it should match. Next important thing, sometimes your data may have null. If you don't add this particular condition, your partitioning will fail. So always, as handling null values, whatever partition you are using, make sure you are adding that clause which is not null. Clear? These are very, very important points about creating a partition. So what is our new table name? My orders. But what is the speciality of my orders? It is partitioned by one column. Orders table, it was not partitioned. How will you know? I will show you. Where? After?
Second line.
After sitting.
Before select.
We have and there is a typo.
Two closing brackets, one opening bracket.
There is typo order underscore status.
Wait. Where is the bracket missing?
Above line. Yeah,
Yes,
that,
yes.
go back. Yeah,
There is a spelling mistake. Okay.
And the closing bracket. It's only closing bracket.
that one. Yeah.
We need opening the
Ah, okay. Sorry. Is it correct now? Select. Yeah, no bracket. Correct. Right. So that's the complete command. And press enter. Very good. It's expected, and I want that error to be read. That's why it's not written in my notes. Dynamic partition strict order requires at least one static partition column. To turn this off, set Hive exec dynamic partition mode equal to non-strict. It is clearly telling you what you should do. There is a setting in Cloudera virtual machine and normally in all the Hive environments where they will not allow you to create partitions. So you have to unset it by giving non-strict. So just copy this particular value. Sorry. Just copy this. It is clearly telling you what to do. And then right click, paste. Set that particular value and put a semicolon. Control L, execute that command again. And look at that, total jobs equal to 3. There is something complex going on. And you will see something special going on in that MapReduce job. Can you guess what is happening? Internally, it will create that partition code that we learned in MapReduce. Remember that custom partitioner, and it will attach that partitioner and it will create all that is needed for you. And please look at that. Order status equal to pending payment, order stat equal to pending, order stat equal to payment review. It created all these partitions for you. And how will you know whether there are partitions? Look at this. Describe formatted orders first. Okay. And you can see just it has given you all the 4 column names like this. There is nothing called partitions. And now Control L, describe formatted my orders. And if you look at the my orders, now you will see partition information and order status is partitioned. So remember the power of that describe formatted command. If you go to any company and you want to check whether somebody has done partition or not, describe format. It will automatically give you. Now another important thing is that if you go back now and take your other window and execute the scoop import, if you execute the same query that we have executed earlier, where is the Hive prompt? Oh, I think this is the one. Control L. What is that? Select count star, right? Instead of this, now let us execute it from my orders, because that is a partitioned table, and press enter. You will not see much difference. Why? Because we are dealing with 68,883 rows. But if there are 10 million, 20 million, 100 million, 1 billion rows, you will see the power of partitioning. And if you are now looking at the same place where you went earlier, the Cloudera virtual machine, and if you go back, the original page, you will see another query where my orders is there. Is it completed? Okay, just refresh and you should see the my orders table now. Right? You should make sure that the query is my orders. Where is it? localhost 8088, right? No, I can't see the other query also. Where?
Next, after department we have orders. Below after department.
No, I want my orders.
Yeah, my orders is orders.
Oh, okay. So maybe it is.
It's in alphabetical
Yeah, it is
order.
down in the alphabetical order. Yes. So my orders, that's the last one. And now you click on this and go to history and go to counters and come down to job counters. Sorry, map input records. And earlier it was, no, it should not be 68,893. Something is wrong then. Where is our query? What did we write in the query? Control L, select count star from my orders where order status equal to pending. Yeah, that's correct, right? Let's execute one more time. It should show you 7,610 as the input records. It should not show you 68,000. Then what is the purpose of partitioning, right? Let's see. Okay, and we go back. First of all, this window itself is. I will freshly open localhost column 8088. Okay, my orders pending. Now it is the first one. Okay, now click on history and come down. Click on the counters. Technology cannot fail. If you get some value, immediately don't get scared. 7,610, highly optimized. So 68,873 became 7,610, and in a professional production environment, billion rows will become million rows. These are the things how you should use actually the technology. This is the actual use for partition.
I have a question. Now we are done with the order status, based on order status, they will suppose if I want to query with other column in the word class, so it will treat the normal table now, or how it will
It will scan all the entire rows, no difference, no difference at all. Then you have to add another partition column, right? That's how exactly you'll have to do. Okay, it's same as Oracle or something like that, right? And now in the exam and all, they will be telling you like this: make sure that the orders table is partitioned. But you created a temporary table called, you created another table, my orders, right? And your exam, I told you, an automated robot will check whether the orders table is partitioned or not. It is not partitioned, and you are not going to get any credit, 0 marks for doing all these things. So how will you do that? The orders table, you have to make sure that the orders table is there. So what I have to do is alter table orders, and this is a new command, rename to backup. So I am renaming order table, and now alter table my orders, rename to done. Now your order table is partitioned, correct? This is complete steps. Now your robot program will look at the orders table. Yes, it is highly partitioned. Okay, so I'll pause partitioning. Clear? Anything, everywhere, whenever you are reporting into Hive and all, take care of this. This is how you should do the performance improvement. So if there is an Oracle table, you are using Scoop and you are bringing the data to Hive, but in Oracle it is partitioned by, let's say, a claim ID or a credit card number, but in your Hive, for analytics purpose, you want to partition it by date. What you should do? import it and change the partition to date. So you have now, one shot and two birds, correct? Whenever you want to query based upon the claim ID or credit card number, query Oracle. Whenever you want to query by a date, query Hive. This is how big data is to be used, right? So I'll stop this video here.